All right. Just check really quick for the online students. Can you hear me? All right. Online students, can you hear me? Okay, thank you. All right, let's get started. If you check the email, if you still didn't have any information for your AD2, please email me your username and the Purdue ID. Okay, so I can ask someone check for you. Another thing is, remember today is the deadline for Lab 1 and 2 write-up, and also the actual credit is due today. All right. Yeah, and hopefully you already finished the pre-lab of Lab 3. Okay. Any question before we get started? All right. If not, let's get started. Okay, so first of all, I want to quickly introduce the equipment on your benchtop. Okay, so although most of the time, or even for the online student, you are not going to use those equipment, but I still want to introduce those things really quick. Okay, so first of all, on the right hand of your benchtop, there is this equipment on your right hand. That's the power supply. Okay, if you check, there are two supply pins. So one is 6 volt and minus 6 volt. So that's limit. The maximum comes from this 2 pin is positive 6 or negative 6. And another 2 pin is 25 volt. Okay, plus 25 and negative 25. Okay, so that's the power supply, which you already use in your AD2. So that's the same function of the supplies in your AD2. All right, and in the center, okay, there are two equipment. The top one is DMM. Okay, so this one is the same function of your handheld DMM. Okay, but this one may have more function in here. This one can measure the capacitance, I guess. Yeah, but basically it's very similar with the one you have. And the bottom one in the center, that's the wave gen. Okay, that's the waveform generator. So it's the same thing of your wave gen. Okay, similarly, this one have two output, channel 1 and channel 2. Your AD2 also have channel 1 and channel 2. Okay, so this one, yeah, it can gen sine wave and triangle wave. Okay, so it have a very similar function with your personal AD2. Okay, and then on left hand of your benchtop with equipment with big screen, that's an oscilloscope, which you will use for today's lab. Okay, so since you are using AD2, so it will use something called scoop. Okay, it's same function of this one. This equipment will detect the AC signal. Okay, so you generate AC signal from this waveform generator, and you can detect the signal from this oscilloscope. All right. Okay, so I don't think you will use this for this method. It's just good to know. All right. Let me share my screen. Okay, so today will be Lab 3. Okay, hopefully you already read through the menu. Now what will be on for today's lab. Okay, so today there will be 4 tasks. The first one and second one are kind of similar. Okay, so for task 1, you will use the wave gen to generate a sine wave. Okay, so if you already done something in the lab 2, okay, you use wave gen. to generate a sine wave with those requirements. Okay, so one thing you need to pay attention is this signal is the peak-to-peak voltage is 2 volt. Okay, you need to know what's the difference between peak-to-peak and amplitude. All right, so the peak-to-peak is when you have a signal from the top point to bottom, that's peak-to-peak. So for example, in here, this signal have 1 volt amplitude. Okay, so that's mean from the center of your signal to top. Okay, this distance is 1 volt. Okay, then when we transfer to peak is plus 1 volt to minus 1 volt. Okay, so that's peak to peak is equal to 2. Okay, so you need to know 2 times amplitude is equal to peak to peak. All right, then after you generate the sine wave from your AD2, and the sine wave should be come from the W1, okay? And then you will use 1 plus to detect the signal. Okay, so 1 plus. So you just directly connect W1 to 1 plus, and you open the scoop in your AD2. Okay, so if you open this scoop, okay, so you can detect the signal. All right, then the question, you can do the question number 4 and question number 5. You need to adjust the horizontal scale and the vertical scale. What that mean is, okay, so this will be the screen that you can see the AC signal. Okay, so you can adjust this screen. Okay, you can change the scale for x-axis and y-axis. Okay, so the x-axis, it will be the time scale, and the it's I mute. Okay, yeah, still. You need to turn off the speaker. Yeah. Okay, thank you. Yeah, and the y-axis, that's the voltage scale. Okay, you can change the scale by changing the number in here. Okay, so this is change the time scale. Okay, you see if I screw my mouse, I can change the time per division. Okay, so for example here right now it's 1 million seconds per division. That's from, you see there are some grid on the screen. Each grid is 1 million second. Okay, that's x-axis. And then if I can also change the y, y-axis scale. Okay, so for example, right now it's 1 volt per division. That's mean per grid. Okay, per square here, that's 1 volt. Okay, and also there are 2 channels. Okay, you can change both of them. Okay, and the channel 1 is 1 plus. Okay, and the channel 2 is 2 plus on your AD2. All right, so after you adjust those 2 functions, you should be able to satisfy this question number 4 and question number 5. All right, and then for the question number 6, you will need to measure the peak-to-peak voltage and the frequency by a cursor. Okay, so what is cursor? You can find the cursor in here. Okay, so you have Y cursor, X cursor and Y cursor. Okay, the X cursor is using to measure the frequency. Okay, so you just change the cursor from a start of 1 period to end of, so the first line will be the start of 1 period, and the second line will be end of 1 period. Okay, so you see the time difference will be the, okay, delta x, that's the time difference. That will be 1 period. Okay, you can calculate the frequency. Frequency is equal to 1 over period. Okay, so 1 over 1 millisecond, that will be your period frequency. Right, so that's for the frequency measurement. Then you can use the Y cursor, measure the peak to peak. Okay, easily you move this line to top of your signal and another line to bottom of your signal. You should able to see the peak-to-peak voltage here. Okay, so the delta is the difference. That's a peak-to-peak value. All right, so that's how you use cursor to measure the frequency and the peak-to-peak voltage. Okay, don't forget to take a screenshot with those cursor on your screen. Okay. All right, so that's that's task number 1. Okay, then task 2, you will do something similar, but you will use a triangle wave. Okay, and with the offset of 2 volt, peak to peak, 2 volt. Okay, remember peak to peak, 2 volt. That means amplitude is 1 volt. Okay, so for question 3, adjust the echo position and the scale so that ground echo is visible. Okay, what's ground echo? On your oscilloscope screen, there are 2 arrows. Okay, so the arrow on the left, so this little arrow, that's the ground echo. Okay, the arrow on the right, that's the trigger, which we will use for next step. But for today's step, remember this thing on the left, that's the ground echo. Okay, and yeah, then you can do something similar. You just adjust the horizontal scale and also the maybe the vertical scale to satisfy this equation. I mean, satisfy this those 2 questions. All right, let's see. I forgot something. Okay, so I forgot something in task 1. Okay, so for task 1, number 3, you are asking to press auto set. Okay, so where you can find auto set is in here. Okay, so you need to click this letter, this down arrow, and you have this bar. Okay, so click this is the auto set you will need to do. Okay. Right. So go back to task 2. Okay. I'll turn off the speaker. Okay. So task 2. You need to adjust the vertical and the horizontal position. Okay. So which you can do is you can directly drag your signal. Okay. To adjust the position. Okay. And also you need to adjust the horizontal and the scale number in here. Okay, the position you can also change it. Okay, for example, I'm moving the position right now. All right. Okay, yeah, just play with those functions. You will know how to do this. And then for the question number 5, you need to measure the peak-to-peak voltage, the frequency, and also the average value, which is offset, by using the measurement tool. Okay, so where you can find the measurement tool is here. Okay, click the measurements. Okay, you can the AD tool can automatically help you to measure the value. For example, you can measure the average and also the frequency. Okay, so you see the number will measured for you by the software. Okay. Yeah, I think that's task 2. Similarly, you need to take a screenshot with the measurements is displayed. Okay, then task 3, you will generate a very slow signal, which is only have 0.2 hertz. Okay, that's a very slow signal, and you will generate a sawtooth wave, which increasing with time. Okay, how you can generate the sawtooth? You need to generate a sawtooth signal from the triangle wave. Okay, and increasing with time. That means you need to change this symmetry to 100. You see here the signal is increasing with time. So that's sawtooth increasing with time. All right. And if you change this symmetry to 0, so that's also a sawtooth signal, but it's decreasing with time. Okay. All right. And then you need to just follow the instruction. And for question 4, you need to set the oscilloscope to roll mode. Okay. So the roll mode is these things in here. Okay, so you can change the mode in here. The roll mode is the shift. Okay, so that's the roll mode for AD2. Okay, also the instruction is in here. You can find out. Okay. Yeah, I think that's all you need to know for task 3. Okay. Any question for first 3 tasks? Okay, the first 3 tasks are kind of similar. You generate a signal and you let the oscilloscope to detect it and measure the frequency, voltage, or the average value. Okay. All right, no question. Let's go to task number 4, the voltage division. Okay, so hopefully you already read through the menu. Give me 1 second. So in the section 3.6, there is an introduction for voltage divider circuit. Okay, so you need to read through this and remember this equation. Okay, so this is the circuit for the voltage division. Basically, it's just 2 resistors in series, and you measure the output. Okay, the output is the voltage cross second resistor. Okay, the voltage is equal to input voltage times R1 plus so R2 over R1 plus R2. Okay, so remember this equation. Okay, so in this task, you will need to use the components called potentiometer, okay, or whatever you call it, potentiometer, whatever. Okay, so that's something looks like this. Okay, you can find this in your lab kit. Okay, basically, there are 3 pins for this component. Okay, so let's call these 3 pins A, B, C. Okay, so what's inside is something looks like this. Okay, is inside these components there is a resistance strip. Okay, when you tune this little knob, this pin is tuning. Okay, let's say for right now, if you're okay, so for totally from start from pin A to pin C, the overall resistance is 10K. Okay, so the maximum resistance will be 10K ohm. So how this work is, for example, when you connect pin A and pin B to your DMM, you measure the resistance. Okay, so then when you tune this little pin here, if you tune this pin to most left side, okay, which means you directly connect pin A and directly go to pin B. So then when you measure the resistance by your DMM, the resistance will be zero ohm. Okay, so because you're short pin A and pin B by tuning this knob to most left side. Then maybe you can try to tune this little knob to the middle of this resistance strip. Okay, then the number on your DMF will be about 5K ohm. Okay, because the current only go half of this resistor strip. Okay, so that's half of the 10K will be something around 5K. Then what you can try is you can try tune this pin to most right side of this resistor strip. Okay, so then the DMM on your the number on your DMM will be 10K ohm. Okay, because the current goes through all this resistor strip. That's 10K ohm. Okay, so basically that's how these things work. Okay, after you know the function of this potentiometer, you need to build the circuit. Okay, the circuit is something looks like this. Okay, so basically this R1 and R2 is just this potentiometer. Okay, so that's pin A, pin B, and pin C. Okay, because there are 3 pins for this potentiometer. And the pin A is connected from the voltage source. Okay, so for this task, you will generate a sine wave, which means that's pin A will connect to W1 on your AD2. Okay, and the pin B is your output. Okay, and the pin C will connect to ground. Okay, so pin A is your input, which you want to detect the signal by channel 1 or channel 2, depends on you. You can use 1 plus to connect to pin A to detect the input signal. And then you can use channel 2, which is 2 plus, connect to pin B, which is the middle pin. That's the output voltage. Okay, in that case, you can detect the input and output at the same time. Okay, so that's connect input of circuit functionator and input to oscilloscope. Okay, and the output to oscilloscope. Okay, so the input is pin A, connect to channel 1. Output is pin B, connect to channel 2. Okay, so that's how you build this circuit. And don't forget, you need to connect pin C to ground. And also, this component is symmetric. Okay, you can choose either the first pin, pin A, or first pin, pin C. Okay. All right. And then when you tune this little knob, you will see the output voltage change because the value for R1 and R2 is changing. Okay. Yeah. I think that's all for today's lab. Any questions? Yeah. Okay. Yeah. Welcome. Yeah. Any other questions? If there is no questions, you can start to the labs. Can you try click on the range? So for channel 1, on your channel 1 part. Okay. I go to your wave gain. Okay, that seems right. I go back to school. Yeah. One second. Yeah. Give me 1 second. Let me check my. Seems like your. Okay, your signal amplitude seems not correct. So because you're generating a 1 volt sine wave, but the waveform is not sine wave. I mean, it's sine wave, but not 1 volt amplitude. Can you try reconnect the 1 plus? Okay. Try to connect the ground to 1 minus. Still same thing. Okay, about that after I have it. Still not. Try to increase your amplitude in your wave gain. Change to like let's say 3 volt. Yeah, I thought you meant like when you were setting the wave. Okay, go back to school. Okay, and maybe auto scale. I just realized yeah. Okay, it seems like your signal is 10 times smaller. Let me see why this happened. But like the equation is Give me 1 second. Let me check my. Can you try reopen your waveform and do the same thing? Meanwhile, let me check my. Or try to use channel 2. Use channel 2 like from 2 plus to W2. Yeah, try both of them. Let me check my.
So it's like 1/d is that's because they give us they already have everything. And it looks so cool, right?
Yeah,
Thank you.
flip it around.
Yeah, thank you.
The left side is for the ground.
Yeah, so did you
Wherever the triangle is, that's where you have your. You can just click and drag. Yeah, that just shifts the ground. So, and that one is for triggering. You use that. Yeah, as long as you're getting the.
Seems like your channel 1. Channel 2 looks fine, right? So what's your channel 2? Go to your wavegen. What's your channel 2? Okay. Yeah, that seems correct. I think you can change to 1 word per division. If you want. Okay. Something wrong with your channel 1. Yeah, maybe use channel 2 for right now. Maybe we can arrange a meeting later to say can I fix your channel 1. Yeah. Yeah, I think you need to use both of channel next time. So we need to fix your channel 1 later.
But since this is so slow, in the small time it takes to sample, it actually gets a very, yeah, very wrong.
Okay, so there is the student asking step 4 of task 4. So it's asking to generate by tuning the potentiometer. You can say 1 volt peak to peak at output. Okay, so what's the input and output is, so you're building this circuit, right? So this is Vin. Okay, Vin is directly connect to PNA on the display by channel 1. Okay, 1 plus is your channel 1. Okay, so that's input. Okay, the input cannot be changed. The only thing you can change is the output. By tuning this potentiometer, the value for R1 and R2 will change. So you can say the output at pin B, okay, so which will be channel 2 of the 2 plus, okay, channel 2, which is 2 plus. So you can see the output change. And you want to tune this potentiometer, so you can to satisfy this requirement. Okay, so overall, so this pin B is your output, pin A is your input. Does that answer your question? Yeah. Yeah, if you are connecting the circuit like this, channel 1 is your input, channel 2 will be your output.
Yes. The.
Why 2 volt output? Okay, input is offset is 0. So the input is forward peak to peak. So this signal is this input. Okay. So you need to check the output. Maybe what you can do is try to build this circuit. Okay, and you should say what's the meaning for this question. After you tune the potentiometer, you should say the input and output is changing. Okay, and then we can talk about this after you build the circuit.
Yeah,
okay. So are you able to see the output change when you tune this potentiometer? Yeah, that's correct. So only output change. Because your input is directly connected to Vin, right? So only when you change Vin, you can see input change.
One plus to the double.
Okay. Signal has an offset of 2 volts. Did you make sure your input does not have any offset? Like, did you make sure this offset is 0? Okay. Do you want to share your screen so I can check your oscilloscope? Or you can send me a picture of your waveform. Okay. Okay, I see what you mean.
What
The offset.
So,
So,
it's my bad, actually.
actually, so there are you need to make sure the ground echo for bus signal at same level. Okay. So you don't want to do like something like this. They have different level. It's better if you can put two ground echo at same level, so there will be no offset.
Zero. Get it over here. We need to move it on.
And then, what does it mean by scales the ground icon?
I think it's these.
Okay, zero.
Where that's zero.
Yeah, okay, so that's zero.
Oh, wait.
Mhm.
And I think
So that's what it's like to do it, so
let me put that in one. Offset is one though. Let me
It's done.
I got his deck so many times, so you never.
Yeah, but
It never feels good.
what's the scale? Oh, we're using this.
How do you
It's
Hold on. Hold on.
now you have one at the like middle division, right? The center would.
We're just zoomed in really. Okay.
Does this, that's like the ground, right?
Yes, yeah,
Okay,
That's what they mean by exception.
yeah, I think so.
yeah. So wherever you have this little triangle, that's where you have your ground.
Okay. Got it. Alright, I don't think it's so mine. Yeah, I think it's pretty good, but.
Wait, we aren't really using channel two. Channel two is used with like 2 plus and 2 minus. So yeah, you can- but,
How do you turn that on? Oh.
You want the
That makes sense easier.
Yeah, yeah. Like you just move the ground thing down. Whatever you have.
I have one of my graphs in the back of the.
Yeah. And
Second story and everything.
if you want to set it to like the side one, you can use that. Yeah.
We do the same thing as we did before.
Yeah, but I think the first one you use cursor. This one will be the measure. Define. The vertical one would be for the voltage peak to peak amplitude and stuff. The one with the angle constant. Yeah, it's voltage is one vertical. Frequency will be in horizontal. Average will be in vertical. Like if you just frequency drop down.
So what all do we need to include in our write-up? Like, would it be, we would show like a picture of the triangle wave that we generate kind of stuff, or do we
Yes.
just,
You
I don't really have to show like step by step us doing everything, or would it be like?
no, like you have this, a screenshot of this window.
Yeah, so it says capture a screenshot of the oscilloscope display. So like that, of course, I'm gonna take a picture of that, but does it, when it says like, set the 82 wave gen 1 to create a triangle wave, would we need to include that? Or is
No,
it-
no, you
Okay.
make it into that. But you also have these measurements tools.
Yeah, so it would be like the
Yeah.
calculation, and then,
And
like
the error, yeah.
the picture and then, okay. Thank you. Yeah, so I'm like, trying to put every step in here, and what's the deal? Yeah, that's,
You can even put some.
yeah.
If you look at it carefully, this is exactly one. So initially it's very low, then exactly right, the bottom of the family over. But then we get to the visible portion. So yeah, that's what it that you're like kind of able to get an idea of it.
Oh, okay. They're gonna make sure that keep that somewhere. So the alignment, maybe the top of it. Like this one.
Also learning how to use an 82. Because I took this class when we used the equipment. So I'm like,
vision here.
Mhm.
I had a question here. So they tell us to refer to figure 3.4. So we have like resistances and so. So my question is, how do we join this to the end of this?
So essentially, if this is your potentiometer, then these three are the same.
Okay. So it doesn't matter for like flip to the other side.
Well, yeah, then you'll have to rotate it clockwise instead of anti-clockwise. You're just changing R1 and R2 with that.
So I can like, so 4.8, this is the first resistor, right?
Let me show you something. You have your a multimeter. You can actually measure the resistance between these two pins. So the resistance across these two pins remain constant. That would be R1 plus R2.
Yeah.
If you move it all the way clockwise, then all the resistance will be between these two pins. These two pins will be shorted. And if you gradually move it this way, then you're essentially what you're doing is making R1 smaller and R2 larger. So you're just shifting it right.
Right. So like I had a down like making the connection itself. So I can like one idea. So I put W1 connected to the first point that's in line with this.
Yeah.
And this to the ground, right? So now the middle connection is where I have a doubt. So I was thinking of maybe connecting this row with this row and like connecting these 2 points.
No. So in this one, what do you want to just like divide your W1 thing, the output from W1, and get that thing, get the output into your oscilloscope, right?
Right.
So like if your W1 goes to the rightmost pin and ground is at the leftmost pin, then the output at the middle pin with the ground. That is the thing that you'll feed to your oscilloscope.
Oh, okay. Because that's measuring the out.
Yes.
So to complete the circuit, it's just these 2 points, and then I feed them all over.
Yeah.
So it's good.
What? Yeah. On the side. Yeah. So since this is a very low signal, yeah, it works this way in auto set. But if you like set the mode to shift instead of that, and now if you manually like make the ranges. Yeah. For the
Me too.
also with the other so you can actually yeah shift as well. So
I was gonna ask you, like what, like the measurements are very small, so they go to each other, so I just.
yeah. Just need to like remove them.
Like,
Yeah, just give a figure ID.
yeah. So, do that 500 volts. They want to be able to see multiple.
Yeah, yeah, all of them are there. I guess in this point, like get the original one in channel one and the divided one in channel two. For now, wait, it's that. Build a voltage divider, connect the input of circuit. And yeah, so like basically whatever you connect with one plus and one minus, that's the what do you call it?
Yeah.
Channel one, and 2 plus and 2 minus is for channel two. Yeah. I guess the thing that you have currently connected with channel one goes to channel two, and this W1 should also be connected to the first. Yeah, channel one.
Solve.
Give me 1 second.
Why? Yeah, that's the offset. So like. You took that.
So like that's not,
So then if you sum those, the average. Yeah, because that's the offset.
oh, that's what it is.
Yes. Yeah. Well, in this circuit, we haven't connected the VR yet. Yeah, this is good. So the blue one and brown, right? Here. So now, like what this is, that it essentially is like two resistors, one resistor and one resistor. And if this is like one of them gets smaller, the other one gets larger.
So, yeah. Okay, so.
Yeah, how do you make it increasing?
Do you know what people kind of are?
Yeah.
I'm trying this ramp up thing.
No, I figured it out. So it's a triangle where you put 100%.
Oh,
And I'm feeling that in fusion that many more will come.
Yeah.
Yeah.
Those are like, not even.
Exactly.
okay.
And then you just put that on the wall.
Oh, okay.
Okay, no.
I'll get the deal. Yeah. Yeah. Just like yeah. I mean, the scale is basically this thing like you have 2 seconds for the yeah. Yeah.
It's this is
Okay.
yeah, so we count it.
Well, I think we. Yeah. If you make it triangular way. This is just a soft way.
Well, how
It is increasing. Like it goes from low to high.
Did you change it from triangle?
Now. You set the symmetry. Yeah.
also is the given
It's increasing because like you can flip it around.
Then have it be 60.
Yeah.
also that's
Yeah, that's just all I mean, but increasing. It doesn't mean that it's like a, it just means that it goes all this direction.
Yeah.
It's kind of cool.
What are you doing?
That's all. This one's stuck. But how do we build it based on?
So you plug one in. You plug the plug in the W1.
Yeah.
Wow.
Even with the
Hitting 0.914.
It's not
It
impossible.
has like two variables, it has two variables in 0.9. Exactly the same.
Should be low enough.
Until 1.8.
When you like
Do you see anything on the phone? I mean, it's just that.
and that is one of them is real.
Honestly,
The other one,
I mean,
as it was,
Yeah, I guess that's something to add.
this was that.
what is yours? It's like, I don't know.
Oh, it's just this. Where,
Oh, you have that in code?
no, why did?
Yeah, we have the same thing.
Yeah, just in it. I think it's just what my screenshot. Like, it's mine showing 10 seconds.
Mine
It's
showing
fine.
1.
I'm not sure. Well, you can see now.
Yeah.
Exactly.
Yeah, the one who was like, I really got it right now.
Why don't you just pick one?
And I think you did it once. You.
Well, that was a bad idea.
That's not a good idea. Yeah. And now if you connect to the other one, you will get the W1 yellow. And
ship with the television.
Okay.
So,
Yeah. I did it like that. So, that doesn't matter. That doesn't matter.
That would be
What do you think makes you that one?
So you don't need to pick up the one right, and I click on the last one. If you like connect 1 minus and 2 minus to ground, then you won't get it to be so shaky. Have you done that? No. So yeah, just 1 minus. Yeah. Wait, 1 minus and 2 minus 2. The last. And yeah, this one is. Wait. This is. Yeah, and these have to be connected to ground. Like, oh, this thing also goes to the ground. Okay. Yes.
Okay, so there is the students
I just had a question
asking
this on. So,
about the task 3 question or step number 5. So how to adjust the horizontal and vertical control. So that's the waveform is 4 division tall and center vertically. Okay, so how to change the waveform to 4 division tall is you need to change the range for y-axis. Okay, so for example, right now my amplitude is 1 volt. Okay, so peak to peak is 2 volt. Okay, so if I want my signal 4 division tall, I will change this to 0.5 volt. Okay, so that case, the signal is crossing 4 division. Okay. And then for how to change the signal center, is you want to stop and drag your signal like this. Okay, so your signal can. For example, I want to this peak center, so I can drag this signal like this. Okay.
I have this one on this part. This part. Yeah. Yeah. So like, so one and yeah. So you can actually double. It's not a middle, I did 2 plus. So we're going to minus 2 minus 3. After this one, connect these two.
Okay, there's a student asking what's the ground echo. So this little triangle here, that's the ground echo. Okay, you need to make sure it's not something like this. You want to make sure your ground echo is fully visible in the screen.
like, when the one plus back from the one.
Yeah.
What is it?
Yeah.
Yeah, sure. Are you able to join the So, what is happening? You know that the ball is gradually increasing, and then it suddenly drops back. So you kind of can understand the shape of the signal by these numbers, right? So yes, and they just talk about it in one sentence.
Yeah.
That's it.
So dribble? Yeah, I do.
This you have that.
Oh, no.
You're not going to go.
It's supposed to come through YouTube.
I 82.
If you go to,
Yeah.
Yeah. I don't know.
No, you don't actually. Look at it. That's what I want. Because the signal is like this, right? So you notice that the signal rise, back, fall. So you need to just talk about it. Gradually rising. Off the slow wave.
I think that's for task 4. Yeah. Yeah, so that circuit is.
Sorry, that's my bad.
The fourth step is logic, right?
Well, yes, in fact, most one can see. So if we can move it by shift, now I'm trying to look for a role. Because the role is muted.
Yeah.
If you auto set it at that, if you auto set it now, then. Then you can actually see it over there.
I feel like once we get it, it's like, wow, it's really simple, but it's just finding it out.
This one here.
I don't know.
Oh, my.
Roll mode is called shift.
Yeah.
Oh,
Yeah.
so you say that we saw time.
I can tell it's on the ground, you can see how it's progressing, so, or it's just outside of city.
Okay, there is a question about the Lab 2 task 2. Step number 4 and step number 3. Okay, so for step number 3, you don't need to recall any data. Okay, so you just need to build the circuit. Okay, so what you need to build is something like this. Okay, so you want to make sure you have a, give me 1 second. The whiteboard. Okay, so this is a whiteboard. So you will build something like this. Okay, so first of all, you have your W1. Okay, so that's the output. Or that's the signal from your AD2 W1. Okay, so W1 is directly connected to DMM. Okay, so the DMM is using as an ammeter, so which measures the current. Okay, so that's the input is the current measurement pin. Then the output is the com pin from your DMM. Then the DMM connect to one side of the resistor. So then another side of the resistor directly connect to ground. Okay. Then you will use the AD2 to measure the voltage. Okay, so you use 1 plus connect to one side of the resistor. Then the 1 minus connect to another side of the resistor. Okay, which is the ground pin. Then you use the wattmeter function in your AD2. Okay, so you can measure the voltage on AD2, measure the current by DMM. Okay, so remember the DMM or the ammeter is in series of RS. You want to make sure the current goes through your ammeter, then goes through your resistor. And the wattmeter, which is the AD2, the 1 plus and the 1 minus, is parallel with your RS. Okay, so you can check the tutorial video I sent out by the email. Okay, so I think that tutorial is much clearer than what I'm talking about right now. So those 2 tutorials talk about how to measure the voltage and current. Okay. And then after you build a circuit, for question number 4, okay, you will varying the amplitude, okay, by change the input amplitude, okay, the W1. Okay, you can change. You want to change from 0 to 5 volt. Okay, maybe what you can do is 0.5 volt per step. Okay, so you record the data, the current and voltage when input is 5 volt, 0 volt, and then you adjust the amplitude maybe to 0.5 volt. Then you record the current and voltage again. Okay, then you do the same thing until 5 volt. After that, you should have let's say a data table. Okay, you should have something like this. Okay, you have a data table. So one column is the voltage across the resistor. Another column is the current across the resistor. Okay, there are, let's say, 10 points totally. Okay, so you will use those 2 columns of data, okay, to plot the current versus voltage. Okay, you want to plot something like this. Okay, so the x-axis will be voltage, y-axis will be current. Okay, so you will plot the relationship. Okay. So yeah, that's question number 3 and the question number 4. You understand what I? Yeah.
I just did it. Oh. That's a good point. I didn't need to do that. Well, I think the printout's a different thing.
Yeah, the average value is the essentially equal to the offset.
Is there a special way to do the printout? Or last one? Yeah, capture a printout of the source code display, start with a horizontal.
Oh, yeah.
The farm.
Like what?
Oh, okay.
Yeah,
Yeah, I think this one is too big.
okay. So we just screenshot it and then do it?
Yeah.
Okay, and do we need this? In the screenshot or-
I guess.
Okay,
Now make sure you circle the numbers.
okay.
So we're gonna take the look for this.
Yeah. And you want to make sure for your full division hole and then you want to satisfy
Yeah, so 4 divisions means 4 blocks.
Yeah.
So this is 4 divisions, so, and then you this is the center.
I think it's
We have another one.
That would just.
Thank you.
Yeah, see you.
That wouldn't really affect it. Because you have to automatically find the expense.
Are you from? I live there. Where are you from? I'm from. What is it? What is it? Yeah.
Have you looked ahead?
Yeah, those is clear.
Yeah. This is not Friday.
What's it?
I think we have to. I don't know what you're doing. I don't know what our time.
Automatically set it.
I don't know what his Friday schedule's like.
Set it using this one, set it using this one. Because it's the day, and
He is,
it's
maybe like
like
what,
that.
a couple hours pre-dinner.
Gradually it will go down.
We're usually a 7 o'clock in person. In Croatia score.
Yeah, maybe you can take it. Wait for it.
You like have it, yes.
Actually.
Yeah.
Yeah, we don't.
I have to get my sports fix somehow.
Just as we.
Where are you supporting?
I don't know. I don't really have the European team. Because, yeah, I don't know, I like players. So, I guess I told them everything for Belgium because I like Hazard and Lukaku. And then I had an exchange student from Spain, so I like Spain because he was here for the 2018 World Cup, so we watched a lot of Spain stuff. But I don't know. I like all the guys that play for Chelsea, so I like seeing them do good.
He's starting.
Yeah, he's starting in place of Mount. I don't get why he wasn't starting before. I just started him over. I don't know. I still would have started Mount. I probably would have started him over Foden.
I started with the
Yeah, and the.
Manchester City, they had 100 million baseball charity,
He did.
and either Sterling or Ford or Jesus. It's a decent deal.
Yeah.
If you could look for it at 100 million.
That's pretty good. Really?
Yeah. You need a manager for that.
I know. Yeah, you do. You really do. I know Chelsea wants Kane, but I hope we get Holland. That'd be wild.
I don't know, I feel like you need that for one, put it on with it.
Yeah.
Any other kind of state.
True. I feel like I don't know. We got either of them. I don't know how much Pulisic. I don't think he'd start consistently because they would then have like 6 people to pick for the top 3 supposed to. Yeah.
Because you're connecting down.
Are you going on?
I'm just waiting for the World Cup qualifiers for
Yeah.
later on in the year. I don't think they start until September. And then they run for If there were 14 of these, so.
We didn't have USB.
Yeah, but that wasn't Frankie. That was for the fake tournament. Yeah, we won it, which was, I think that was the first time we won a trophy in like over a decade. And but it was good. I mean, they played their A team, and we legitimately beat them. Yeah. I mean, you could say we won on a bull crap
Make a call.
but they got a bull crap player and they got so not safe.
I'm a little.
Our backup saved it, so I can't really complain on the fact that there's saving your people.
Yeah, I can't go through this.
But yeah, if they don't qualify for the World Cup, I'm gonna be mad.
So, first of all, so let's say this is your
I think
input.
they should.
Yeah,
Because
you
I
have
think the cat gets 3
lab
games
port input,
spots,
Okay.
and
which means the
I find it
voltage
hard to believe
plus
we
this
won't be
two
one.
resistors will be both totally will forward. Right?
Yeah.
Okay.
And then
So
certainly
this is,
that's,
let's say, so for example, if this resistor is 5
I don't think
5k ohm,
I don't think
this
this World Cup,
resistor is also 5k ohm,
next World Cup will be
and
completely
what's 12 is off.
I think
That's
this one will be likely to get out of the knockout.
2.5.
But the
Yes,
next World
that's
Cup,
right. And
I don't think
since
term,
this is
but
this
I think we could
posting is a
win a couple
voltmeter,
months.
which is when I tune this potentiometer, those two values will change.
Okay.
Because but these two plugged together will be always 10k ohm. Okay, so yeah, basically that's how it works. Okay, so for example, when I tune this knob to middle,
Yeah.
top is forward, bottom is forward. When I
So we
tune,
gotta do.
so basically this is something like this. Let's say in A,
It's because I had to do that lab last night.
is say
I got my breadboard in this weekend.
here is
So I didn't get to do the homework yesterday.
and here, so that's something inside this is something looks like this. This strip is a resistor strip, or yeah, and
I mean, I did most of it.
when you
while-
connect
while-
this two pin to
you
DMS,
guys have to do the
okay,
injector.
and when you tune, let's say when you tune this to DMS,
There was a tempo.
and when you measure the resistance, okay, when you tune this little pin, you're sure able to see the resistance change in the DMI. Yeah, you understand that part, right? Okay. And so basically what you will when we transfer to this whole thing is something like this. Is this pin A, okay, this pin C, so it's something like A, it has some resistor, okay, and then this is pin B, okay, that's the output.
Yeah.
And then you have another resistor that's connected to pin C.
But the,
And when you tune this little pin or little knob,
there's all
the value for these two resistors is always changed. When
Okay.
you tune this counterclockwise, the value for this resistor is smaller. It's decreasing. And the value I think that the value for this resistor is increasing. I don't know why this happened.
Because if you're like as you turn it, it changes. I don't.
Yeah, because when you tune this like this,
Yeah.
this resistor strip is shorter, and
Yeah.
then the resistance is smaller.
Oh. Okay. Okay.
And
That
when you
makes
tune
sense.
this way, seems similar thing happen, but when you tune this way, this part the resistance strip is longer,
Yeah.
so this resistor value will be larger.
Got it.
Yeah, so that's how this circuit works in here. The voltage is divided by these two resistors, and the resistance is changing and the voltage across this resistor is also accreted.
Mhm.
Yeah, that's how this works.
Okay, and so when we build this circuit,
Yeah.
like the voltage in will just be from the like waveform generator,
Yeah.
and then
And from
the ABC is just part of the potentiometer.
yeah, so if you do have your position,
I don't have it connected yet. I don't have a potentiometer out.
oh, you
But
don't
pretty
have,
much, I have it in my backpack.
Okay.
I just didn't grab it.
Okay.
But so like W1. Oh, okay, that I see where it is now. And so 1 plus is where you connect A, 2 plus is where you connect B, and then C. Does C go to ground?
yeah, see,
1 minus and 2 minus, or you just choose one?
all of them.
All of them.
Yeah,
Okay.
ground, 1 minus and 2 minus.
Okay.
They connect together
Okay.
Yeah.
All right.
with pin C. Yeah.
Awesome. Thank you.
Yeah.
I mean, I just like.
Okay, then.
Oh, okay. Look up your own.
W1.
W1.
Okay, there is a question asking how to do the measure the average. Okay, so you click the measurement. It's
This is the pin out.
I think it's in vertical. Okay, so that's the average. So you see, that's how you measure the average. Yeah, you are not calculating the average. You can just directly measure the average value.
I just connected the Y. 1 minus and 2. The ground here. The ground row. Yeah. That's the one with the knob. It's one of these bad boys here. Yeah.
Oh, no, you, no, it's fine. Just need to use your phone.
In the beginning, it starts with W1. And then, yeah.
If you're not using Connect, like, drawing it, just like for this lab. Oh. Yeah, I'll give it back to you.
Okay.
Yeah.
Yeah, if you don't, I'll hunt you down.
I did that. Thank you.
I don't find strong.
Yeah, we're just saving here.
Okay.
So you have a double on
Okay, let's see. Yeah. Wow. Oh. It's probably really fun.
Yeah, that's
Give it like 82 piece back. Spin is gone. So pretty much you put yellow the W. Oh, so like you have the potential on your right? I put it on the last one of this like one as well. It doesn't matter where you put it. You probably just want it like on one of the sides. Yeah.
Only put your weight in. I know, we're not trying to, that's one of the things to do that. Yeah, I got it. Even for now, it's not actually.
2 plus 1 plus 2.
So W1 is the W1.
Yes, that's connected to the first.
Also, now you're.
Which one is the yellow one? That's W1.
Your solid blue should go. Well,
We connect the W1 to that one plus and then also to the.
and then your blue.
No, so W1 just goes to
That needs to go.
like first, like the A side of the potentiometer.
So the
W1 doesn't go to one point. It just goes to the first line.
Yeah,
Like side of the potentiometer.
plus one, like
That makes sense.
plus one, so you put that. So what is your,
One's here.
sort of right here. So right now, you got your waveform.
Yeah, no. Doesn't make it easy.
Minus one. But it's measuring, but it's.
then we connect one plus.
One equation. So if you put plus two and minus two, you make it.
You don't need one, or no, you need one plus to go to.
And it's what if you might.
Do it differently.
Here. Yeah, so that'll be your blue. So you don't have to add your two, so your yellow or that's the same model. Yeah. So, that's measuring second consider. Oh, because that's three watts. So,
And one goes to W1.
W1 gets the one.
I don't
So
know.
it has one plus with the second one.
Yeah.
It's a fun game.
Play with this over.
Yeah.
Yeah.
What's that resistance?
I know.
Yeah, this is one. So then I connect both one plus and W1.
Here's this one.
What is on the internet?
Right.
Where's A go to? Where's A go to?
One plus. Here. Where does A go to?
I think it goes to one plus. Yeah.
It goes to both 1 plus and W1.
And W1?
Yes,
Yeah.
A goes to both W.
So it should be in the same row.
Yeah, it should be in the same row.
This is a picture.
And then the
Yeah, this is the
second
potentiometer.
row
And then two plus one.
Oh, I see.
And then third row.
Yeah.
Oh, what's it called? And the ground, right? Okay.
Share the rubric for
Three.
Lab 3.
Yeah, I will share Lab 3 on that for maybe later today.
Oh,
Yeah. I think the deadline is not. Oh no, for Lab 3, deadline is Thursday. So,
oh no, the pre-lab.
okay, that.
The
Oh, yeah, I will.
minus to go to third row, right?
B goes to 2 plus. Got it.
This is.
What's up?
No, like, but that's the picture of this one.